We are going to start our new unit today. It's Unit 2, but it's Chapter 3, because Unit 1 we did both Chapters 1 and 2. We're going to be looking at functions and graphs. Today our focus is going to be on the rectangular coordinate system. We're going to take 2 days to cover 3.1. The 3.1 homework will be due on Wednesday. And I'll talk along the way as we're going through the notes today about how you would input things for the homework as well. So let's talk about graphing. We're going to kind of start with the basics, see what you guys remember, see what we need to refresh our memory on, and then we'll start talking about applications of different things with graphing. So this is the rectangular plane, or the XY plane. Also gets called the Cartesian plane. I don't expect you guys to memorize that. You don't have to know how to spell it. But I do want you to be familiar with the word in case you ever see it show up in anything written directions-wise, that's just a normal XY plane. What do you guys remember about this? Tell me everything you know.
X is side to side, Y is up and down.
X is side to side, Y is up and down. What else do you remember?
Origin is 0, 0.
Origin is 0, 0. So this guy right here.
There's 4 quadrants.
There's 4 quadrants. How do we number them?
1, 2, 3, 4.
1, 2, 3, 4. Starting where? Which one is quadrant 1?
Top right.
Top right is quadrant 1. Which one is quadrant 2? Top left. So we go counterclockwise. Quadrant 3 would be bottom left. And quadrant 4 is this guy down here. Beautiful. How do you plot a point?
Do X value first and then what?
Yep, no, you're right.
Okay, yeah, X value first and then value.
Yep. So like this point right here, left and right first and then up and down. So what would that point be right there that I just drew?
2, 3.
2, 3. Left and right portion first, then the up and down portion. Talk to me about the signs of things. In quadrant 1, what are the signs of the x's, the signs of the y's? Positive and positive. So all positive up here. What about in quadrant 2? Negative x, positive y. Quadrant 3? Negative, negative. And quadrant 4? Positive, negative. We have positive x's and negative y's. Awesome. So I want to talk about how we would describe different points. And I'll probably make some sketches as we're talking about this, but what I'm really after here is your verbal descriptions of these different things. So we want to describe the set of all points that would satisfy these conditions. So if I go look at example A here, if I think about that on a graph, what would this look like if I were to graph x equals negative 2? A line. What kind of line?
Horizontal. Vertical.
This one's going to be a vertical line because it goes through which axis? It goes through the x-axis. Where does it go through the x-axis at? At negative 2. So back here we would have our line. It's going through the point negative 2, 0. And so I'm going to take exactly what you guys just told me as we were answering these questions and going back and forth, and I'm going to make a complete sentence out of that. So this is a line parallel to what? parallel to the y-axis, that goes through the point (-2, 0). That describes every single ordered pair, every single point that is defined by x equals (-2). So how would I then describe in words y equals 3?
A line parallel to the x-axis and goes through 0, 3.
That's absolutely correct. A line parallel to the x-axis and goes through 0, 3. C, D, and E, we're not talking about equations, now we're talking about inequalities. When you're thinking about graphing inequalities, what's different about graphing an inequality than graphing a line? Yes, sir? You shade, absolutely. And the shading represents all the points that would satisfy those conditions. So when I'm looking at part C, I want to describe where I'd be shading. Where would I be shading for x is greater than 0?
Everything to the right of 0.
Everything to the right of 0. Or if I want to be more specific, because 0 is just a number, it's not an ordered pair, it's not a point, you would say everything to the right of what?
The y-axis.
The y-axis, not just the origin, but that whole y-axis, because I want to make sure that people know that we're going like vertically all the way across, everything to the right. So this would be all points to the right of the y-axis.
Wouldn't you put like a dashed line on the y-axis?
Yes, if graphing it was the goal of what I was doing right now, yes, I would need a dashed line on the y-axis. I just made a rough little sketch to figure out how to describe in words that whole set of points. But you're absolutely correct. Let's go look at E next, since it's so similar to C. How would I talk about all the points that satisfy y is less than 0?
Everything below the x-axis.
Yep, all points below the x-axis. All right, I held off on D until the very end because this is the only one of the 5 up here where we've got more than one thing going on. It's not just a variable with a relationship and a number. I've got 2 variables, a relationship and a number. What's going on with those 2 variables?
They're both greater than 0. When we're multiplied together.
When they're being multiplied together, they're greater than 0. So I want to think about my graph. Where on the graph could I multiply the values for x and y together and get something back that's bigger than 0?
In the first and third quadrant.
In the first and the third quadrants. Why can we do the third quadrant?
Because I'm using the negative equal to positive.
Yep, because it would be negative times negative, which would give me a positive. So this would be all points in quadrants 1 and 3. Do you guys have any questions for me about these ideas here?
Sorry, why is it quadrant 3 too?
in quadrant 3, are your x's positive or negative?
Negative.
Negative. And what about your y's?
That's negative.
Negative times a negative gives you what?
Positive.
Positive. That's why. Because positive numbers are greater than 0. Positive times positive gives us a positive up here. We doing good? All right. Please stop me. Let me know if you have questions at any point. Who remembers the distance formula? That's slope-intercept form. No, that's okay. Does anybody remember the distance formula?
X2 minus, like, I don't know. It's
Yeah, no, you're
it's like
absolutely.
X2 minus X1.
What's the
Mhm.
explanation for B? Or D?
Y2 minus Y1.
The explanation. All points in quadrants 1 and 3. You're welcome. Yeah, you're like right on the right track. So to find the distance between 2 points, I would say the distance between point A and point B is equal to, distance is always what type of a number?
Positive.
A positive number. So the way I'm going to guarantee that these are positive numbers, mathematically, I can guarantee something's positive if I take it and square it, right? But if I square it, that's not my true distance. I would need to do what then to find the distance? Yeah, I would have to do the square root. So we're going to be squaring and square rooting things to guarantee that we end up with only positive values. I want the distance between my x's, so I want to know the difference between those. So we're going to do x2 minus x1. But when I subtract those two, I might get a negative, so I need to square it to guarantee that it's positive. So that would be how far apart the x values are. Is that the only distance I need to be worrying about? No. I also need to know what? The y distance. So I'm going to do y2 minus y1, because that'll give me the difference in their locations, the distance between them. Do I want you guys to memorize the distance formula? Yes, I do. More importantly than that, though, more important than just memorizing a formula, is remembering what all the pieces mean so that you can recreate this later if you don't remember all the letters. So we want how far apart the x's are from each other. That's why we subtract them. And then you square it to make it positive. You do the same thing with the y's. Square it to make it positive. Add them together and square root. You guys ready to practice with this a little bit? Okay. You with me, Pedro? Not thinking so. Hi. Take that out for me, dear. Thank you so much. All right, let's practice finding the distance between 2 points. So I've got 2 points, A and B. I need to find the distance between them. I don't know about you guys. I have a really bad habit of knowing what it is that I need to be doing. And yet when I look at my 2 ordered pairs, I've got a really bad habit of grabbing both of those as x's, even though I know they're not. So I usually take a moment and I'll label x1 and y1, x2 and y2, just so I make sure I grab the right numbers and I don't do something stupid. It doesn't matter which point you call point 1 and which one you call point 2, as long as one of your ordered pairs is the x1, y1, and the other ordered pair is x2, y2. So I'm going to have 5 minus, but what is my x1? Minus 3, negative 3. So I'm doing 5 minus negative 3 squared. And what happens when I subtract a negative there? becomes a positive. So this is really 5 plus 3 that we're going to be squaring. So I'm going to have the square root of 8 squared. Thank you, ma'am. Do you need a pass? Okay. And then I need to add the difference between my y values. So that'll be 1 minus 6 squared. So I have negative 5 squared. What's 8 squared? 64. And negative 5 squared? 25. Add those together for me, please. What do you get when you add 64 and 25? 89. Can we simplify that at all? No. It's not even, so 2 doesn't go into it. 3 goes into 90, so I know it's not going to go into 89. 5 doesn't go into it. 7 doesn't go into it. 11 doesn't go into it. That's fully simplified. So there's my distance. If we were allowed to use calculators, you could pop it into your calculator. But this is a no calculator course. Yes, sir?
Is this basically doing like Pythagorean theorem?
This is based on Pythagorean theorem, yes. Absolutely. This is 100% based on, and it is derived from the Pythagorean theorem. And that's probably going to come up for us a couple places too. When you guys go to type answers into Canvas for the homework, if it's a radical like this, and it doesn't simplify any further, then you would just type in SQRT for square root, and then inside parentheses put the number that's under the radical. There's a reminder for that when you get to it, but that's what I mean. So if you have an answer like this, you would type SQRT, and then inside the parentheses you'd put 89, and then close your parentheses. Okay? I want to plot these points here. And then I want to show that it is a right triangle. When it says show, that means prove. We're not doing geometry proofs here. This is not going to be written out in sentences. We are going to prove things algebraically. Yes, sir?
Do you need graphing paper?
Graphing paper would be really helpful for this unit, yes. It's okay. Do you need a piece?
Yes.
Okay. Absolutely. Yeah. You're welcome. You know what? I'm just going to send the stickers around, tear one off. If you guys don't have graph paper at home, it'd be a really good idea to go and get some. If you need to still borrow some from me tomorrow or through the rest of this week, that's fine. I can do that, but eventually I will run out of stickers. All right. So I'm going to plot these points. -1, -3. There's point A. 6, 1 is point B. And then point C is down here, 2, -5. So I'm going to plot and label all those points. And then I am going to go through and connect the dots here too. It's much easier to see this thing that I'm supposed to be proving is a right triangle if I connect those dots. All right. Thinking about what we just talked about, distance formula, finding the distance between 2 points, how could I prove that something is or is not a right triangle?
And the hypotenuse will be longer than both A and B.
Hypotenuse is going to be longer than both A and B. Get more specific with me about that hypotenuse. I like this.
The distance of the hypotenuse will be longer and greater than the distance of the other two combined? Or is it just separate?
No, you're very, very, very close. Like you're on the verge of it. Everything that you're saying is true, but that is also true for obtuse triangles. What can I use mathematically that would show beyond a shadow of a doubt that it is a right triangle? Pythagorean theorem. Exactly what you were saying, except when I square the two legs and I add them together, if it comes out to be exactly the square of the hypotenuse, then this is a right triangle. So far, so good there? A, B, and C are all lengths, distances, correct? So what would I need to do here to prove that this is a right triangle?
Count the squares in between. Oh,
So
no,
close.
You do the lines across and up. I don't know.
What did we just do on the previous problem? Yes, sir.
It's like draw an imaginary line for each side. For example, like you like draw it. I don't know how to explain it, but basically like draw two lines that intersect, so it makes. Okay, hold up.
You can. I'm going to go with Carrington's idea for just a minute. What did you say, dear?
Use the distance formula.
We can use the distance formula, which is exactly what you're doing. What you were describing doing is recreating the distance formula using the Pythagorean theorem. But I want to find the distance, the lengths of all of the sides of this triangle so that I can take it and substitute it into Pythagorean theorem, and then I would know beyond a shadow of a doubt that this is indeed a right triangle. So I'm going to need three distances. I need the distance from point A to point B. We're going to need the distance from B to C and the distance from A to C. So I'm going to use those ordered pairs. That helps with messing up when you're counting. Using those ordered pairs and subtracting the difference between them. So I have 6 minus -1, so it becomes 6 plus 1 squared, plus 1 minus -3, so that becomes 1 plus 3, and we square it. Well, 6 plus 1 is 7, so I have 7 squared plus 4 squared. That's going to be, what, 49 plus 16? What is 49 plus 16? 65. So I have the square root of 65. I'm not going to simplify it any further than that, because once I have all three lengths, what am I going to be doing with them? What does the Pythagorean theorem tell me to do? Square them. So I'm going to leave it like this, because when I take it and square it, that square root's going to go away. All right. Then I still need the distance from B to C. So from point B to point C, I would have 2 minus 6 squared, the difference in my x's, plus -5 minus 1 squared, the difference in my y's. So I have -4 squared plus -6 squared. So that's 16 plus 36. What's 16 plus 36? 52. So I've got the square root of 52. And then last but not least, I still need the distance from A to C. So the difference in my x's, I have 2 minus -1, so that becomes 2 plus 1. And then the difference in my y's, I have -5 minus -3, so that becomes -5 plus 3. I'm going to square both of those. So I have 3 squared plus -2 squared. So the square root of 9 plus 4. So I have the square root of 13 here. And now I'm going to take all of those and substitute into Pythagorean theorem. It's really important that I know which one is the hypotenuse, though. Which one is the hypotenuse?
And you
A to B. How can you tell? It's the longest. Even when I look at my distances, that's the biggest number under the radical, right? So I know that has to be the biggest one. So I'm going to take A and square it. So square root of 52 squared. I'm going to take B and square it. Square root of 13 squared is equal to the square root of 65 squared. And when I square these, the square root cancels out. So I'm left with 52 plus 13 equals 65. Is that true? Yes. So now I know for a fact that this is a right triangle. Was that the only thing they asked me to do? What else am I supposed to do here? Find the area. Well, how do you find the area for a triangle? 1/2 times base times height. So I need 1/2 times, what's the base? Square root of 13. What's the height? Square root of 52. When we were proving that it was a right triangle, I didn't bother trying to simplify any of these because that would have actually just made more work for me. But now that I'm multiplying square roots together, it might be helpful. Can I simplify the square root of 13 at all?
No.
What about square root of 52? Tell me a perfect square that will go into 52. 4. This would be 4 times what?
13.
4 times 13. So I'm going to rewrite it like that. So I'm going to have 1/2 times the square root of 13 times 4 times 13. Because anything that's under the radical, I can multiply together with other things that are also under a radical. The square root of 4 is what? 2. So I have 1/2 times 2, and then 13 times 13 is 169. What's the square root of 169? 13. Half of 2? 1. So then I have 1 times 13. What is the area of this triangle? 13. Yes. Area of triangle ABC is equal to 13 units squared. If you're trying to prove that something is a triangle, or you're trying to prove that two things are the same size, and you find that you need to take a square root of things and it doesn't simplify, you don't have to reduce those square roots, because your whole goal is just to show that they're the same. But when we go to find the area, we do want to simplify things so that we can find our perfect squares. Somebody asked me earlier today in 4th period, can't we multiply the 13 and the 52 together and then simplify it? You can, but remember, you don't have a calculator to use on the tests. So rather than multiply those things together and make a huge number that you then need to break down, I would take the 52 and break it down and look for your perfect squares from there. All right. You guys doing okay? Okay. Perpendicular bisector. A perpendicular bisector is a line that is perpendicular. What does perpendicular mean?
Parallel.
Yep. Not parallel. Makes what kind of an angle? Yes, makes a 90-degree angle. It is a line that is perpendicular, makes a 90-degree angle to a segment, and it intersects it at its midpoint. What is the midpoint of a segment? The middle, the halfway point. if M is a perpendicular bisector, so M is a line that is a perpendicular bisector of segment AB, then every point on line M is equidistant to A and B. Let me draw a quick picture of what this is saying. So if I have my line here, I've got A on one side and B on the other side. Perpendicular bisector is going to go right through the halfway point, and it's going to form a right angle. So I'm going to do my best to draw this. So there's my line M. Any point on line M is going to be the same distance away from A and B. So these two would be equidistant. A point way out here would be the same size anywhere I go on that line. Because it's going through the midpoint, and that's the same distance away from both ends, and then because it's making a right angle, that means it's never going to tip closer to point A, it's never going to tip closer to point B. It always stays the same distance away. I want to prove that there are some points that are on the perpendicular bisector of a line segment that we've been given. So I have 3 points here. I want to prove that point C, this point right here, is on the perpendicular bisector of AB. Which would mean what?
AC and BC are equidistant.
Yes. So the distance from A to C is equal to the distance of B to C. If I can show that that's true, then I know that it's on the perpendicular bisector. You doing okay, Carrington? Okay. So what do I need to do in order to be able to prove that? Distance formula. So let's find the distance from A to C first. So we'd do the square root. 5 minus -4, so 5 plus 4 squared. Plus, and then I have -11 minus -3, so plus 3 squared. So I would have the square root of 9 squared, which is what? 81. Plus, -11 plus 3 is what? -8. And what is -8 squared? 64. What do I get when I add 81 and 64? A 100 what? A little bit bigger. 145. If it was 61 and 64, it would have been 125. I'm not even going to bother trying to simplify that, because all I care is that the other distance is the same as that one. So now I'm going to find the distance from B to C. And as long as they're the same, I'm good. So I would have 5 minus 6 squared plus -11 minus 1 squared. 5 minus 6 would give me what? -1, and then we're going to square it. -11 minus 1? -12, and then I want to square it. -1 squared is how big? 1. Plus -12 squared. 144. And when I add those together, I get 145. So is this on the perpendicular bisector? Yes. They both have a distance of the square root of 145. So far, so good? We're going to do one more like this, and then I think that's where we're going to stop for today. Yep, let's do one more. Prove that C is on the perpendicular bisector of segment AB. I'm going to give you guys a couple minutes to work on this on your own, and then we're going to compare answers. When I'm working with fractions in here, I would usually leave them as fractions instead of changing them into decimals because it's easier for me to square fractions in my head. You square the numerator and square the denominator. What is 1/2 minus 7?
13 halves.
Negative 13 halves, yes, negative 6.5, so I'd write that as negative 13 over 2, and I'd square that. So I would have 9 plus, what's 13 squared?
169.
So I have 169 over 4. How do I then add that with the 9?
Make it 18. Wait, sorry, let me look at my board. Make it 36 over 4.
36 over 4. Multiply top and bottom by 4. So we'd have 36 over 4 plus 169 over 4. What do I get when I add 36 and 169? 205. So I have the square root of 205 over 4. And as long as the other one comes out the same, I can just leave it unsimplified. Distance from B to C. I have 4 minus negative 3, so 4 plus 3 squared. That'll give me 7 squared, or 49. And then I have plus 1/2 minus 2 squared. What's 1/2 minus 2?
Negative 3 halves.
Negative 3 halves. So when I square that, what do I get?
9 over 4.
9 over 4. I need to do the same thing with the 49 that we did a minute ago over here with the 9. So I'm going to multiply both of those by 4. Let's talk about ways you can multiply this quickly in your head. In my head, I have a hard time multiplying 49 and 4. But you know what I don't have a hard time doing in my head? 50 times 4. What's 50 times 4?
200.
200. And 49 is one smaller, right? So I'm going to subtract 4, 1 for each time I multiplied. 200 minus 4 would be what?
196.
196 over 4 plus 9 over 4. What is 196 plus 9?
205.
205. So I have the square root of 205 over 4. Is this on the perpendicular bisector? Yes, it is. And we have now proven that. All right. Homework for section 3.1 is due on Wednesday. We have not talked about how to find the equation of a perpendicular bisector yet. That's coming tomorrow. And we've not done any talk about midpoints yet. That's also coming tomorrow. Everything else on the homework, you guys can do. Now, one thing I want to say about this homework, more so than several of the others in the past, most of this one is automatically graded by Canvas. The reason I'm telling you this is that that window for corrections is open for 24 hours after I've gone through and graded them. But when you submit this assignment, any answers that it kicks back as wrong, you can go ahead and make corrections to now. So you don't have to wait until I've graded them to make any corrections to it. Whether you put them in the comments or whether you redo the assignment is totally up to you. But I want to make sure that you guys know that you have that available to you, and then you still get the 24 hours after I grade them by hand to make any additional corrections from there. All right? The other thing that I've done for you this time is I did type in the questions into Canvas. Having your book on hand is still a really good idea, especially if you get stuck. Remember, the answers to the odd numbers are in the back of the book, so you can check your work that way. Find a similar problem and work through it and check to see if you're doing it right. Have a great one, everybody. I'll see you tomorrow.